So hi, today I had fun with a little bit of alchemy and I converted this into this. Let me show you how I did it. So on the bench here we've got what I intend to actually plate. So this is actually a knob off something I made for the lathe. It's made of brass, it's threaded M8 and it's about 24-25 millimeters in diameter. So I reckon that surface area then is about 18 to 20 square centimeters, and that gives me a current that I need of about 300 milliamps in order to plate this successfully. Now this is a little bit mucky, it's going to need a complete clean before it can be done, and to electrically connect it I'm going to use this piece of threaded rod, stick it in the end basically, and then put some insulation on the rod because I don't really want to plate the rod as well. Okay, let's have a look at what I'm going to use for power. So the guys that sent me the part sent me this. So this is actually some resistive wire, probably nichrome I'm guessing, attached to a piece of plastic, and it's pretty bloody awful. Caution, hot wire it says, and yeah, indeed it will get hot. The idea is that you connect this up to something like a battery charger, 12-volt battery charger, and then you clip one end to the positive and the other end you kind of move a crocodile clip around to control the current, and of course you need a current meter to measure it. Now I don't want to do that, that's pretty awful, and I think it will be hot and a bit dangerous, and yeah, I really don't want to do that. So those of you who watched my previous video will see me modify this Longway 30-volt 5-amp supply so that it is now a current source instead of a voltage supply, and yeah, there's this little board and mounting bracket in there. So I'll link into that video for those who are interested. I didn't actually show this board mounted in its final position on that video, but yeah, there it is. So pretty neat, it's fine, and I did a lot of safety improvements on that as well. So let's get the lid back on. Okay, so first job is to mix up some alkaline cleaner, and see if we can find that. There it is. Now this doesn't have to be particularly super duper accurate measurements. For alloys like brass and stuff like that and copper and things, we are looking at somewhere between 10 to 40 grams per litre, and a temperature in the region of 20 to 70 degrees centigrade. So yeah, so I'm just going to mix in, I think I've said I'll use 30 grams per litre, and the reason I'm using 30 grams is simply that I want to use it for other things, and that's kind of in the middle of all of the ranges. I know people think the health and safety speeches are a bit daft, but you know, sodium hydroxide, really nasty stuff. You know, dissolves all the fats in your skin, pretty horrible burns, and yeah, we're going to be using some acids after this, and then we're going to be using some nickel substances after that. So generally speaking, yeah, if you do get it on you, flush it with a lot of water. If it still stings, seek advice. The key thing here isn't your gloves, isn't your goggles. You do want to wear those because you don't want this in your eyes. But it's actually having a safe approach to work. Notice that as soon as I finish with this stuff, I seal it up again. It's double sealed, and yeah, put it to one side, out the way, and take your time, get it right, be safe. More like it? Right, okay. If you do want to measure it accurately, then what you do is you fill this up a little bit lower than it should be, add the weight of chemical, and then top it up to exactly the right level. But don't do that in a flask like this, do it in an actual proper measuring cylinder. So I now need my acid pickle. Here we are. So these are dry acid salts, and primarily sodium hydrogen sulfate, which I think is sodium bisulfate, and sodium fluoride. You can just make this out of citric acid or something like, well, sodium bisulfate, in fact, not sodium bisulfate, not bisulfite. So I'm going to add, what, about 70 grams of this roughly. Okay, I think I might put a bit much in here, but Hopefully it will dissolve over time. Okay, that's almost dissolved. Let me just move that out of the way as well. So I'll put my jugs in order in the sink. Okay, so this is distilled water this time. And yeah, I'm just going to pour out a little bit more of that. And this is heated up to about 35 centigrade. And yeah, I'm going to actually add now then the chemicals to make the actual plating solution. And I'm going to make 2 litres of plating solution. 400 grams of nickel sulfate. Just get my piece of paper off the scales, that's better. So let me check that again. 400 grams per 2 litres, okay. And just pour a little bit more out just to make sure that I do not end up with too much of the damn stuff. So as I said before, you start, thank you. You start life with too little and then add your solids, dissolve them and then make up the difference with a bit more distilled water. 400 grams. So this is quite a strong solution that we're making here. Again, we don't need to be ridiculously accurate. Again, just as well, because I'm about 1% over, but you know, 1% between friends. Adding the second component, which is nickel chloride, and I need 88 grams of that. So 0 the old scales. These, by the way, are 5 kilogram scales with 0.1 gram precision. So although I'm just kind of dumping these chemicals into here because I want to make the point that this isn't a precision piece of analytic chemistry, I would still suggest actually that a better way is to measure out the chemicals first onto kind of like, you know, you can make little paper holders for the chemicals. Just fold up some paper into a little dish shape, or use some little tubs or something like that. Measure out the chemicals first, then it makes the whole mixing experience a lot easier. But anyway, we'll press on the way I did it. And this should do it. Near enough. Right, okay, cool. Finally, well, not finally, but 64 grams of boric acid. Give that a little bit of a stir before we add the boric acid. So you can get this stuff really, really easily. It's not a problem. Yeah, interesting. Yeah, there's an undissolved scum on top. I'll probably just leave that alone. It might just go away on its own over time or as we start electrolysis. So that's pretty much everything dissolved. So finally, because I want bright nickel, I need to add some of this, which is nickel bright now, which they don't tell you the chemical composition of, but I'm sure I can find that out if I try. So here's 100 milliliter measuring cylinder. So nickel brightness, so not 230, 92. And that is 92. And that is all of them. And we're about 20 millilitres too low. So I started off with 1.5 litres and we're nearly at 2 litres now. Great. And finally back here I've got some warmer, quite warm liquid with which to top up to my 2 litres. Okay, so I've got a pH reading of 4.8-ish, just dropping, adjusting for the temperature. Yeah, so 4.4, about 4.4. I'm not going to wait any longer on that. And it should be in the range 4 to 4.7. So 4.4, nice. So I reckon I'm about half full this tub. Okay, so we're kind of pretty much prepared in here. We've got the liquid, we've got our anodes in there, which are titanium wire and nickel blocks. And before I progress any further, I have got to get this guy that I'm actually going to plate absolutely spotless. So I'm going to start off with brasso and actually do some normal mechanical cleaning and polishing. I'm sorry, there's nothing you can do about this. You just need to apply some elbow grease. So this guy should change from dull to shiny. If you've got a mechanical buffer, yeah, of course you could use that. So, okay, I think we might be about there with that. So there's various ways then that we can do the next stage of cleaning, which is kind of like a degreasing section. I'm going to actually tighten that on, and I'm just going to protect this stainless steel that I've attached it to, because as I say, I don't really want to plate my stainless steel, nor do I really want it immersed in my cleaning solutions and things like that. Okay, 1 to 10 minutes. It's looking pretty damn good. Next, acid. Oh, okay, 0.2 to 3 minutes. So I think there's a tiny bit on one side that isn't quite as clean as it should be. And you know what, I'm going to leave that there just to see the difference that it makes to the plating. What's the point in having a little experiment and play if you don't learn anything from it? Just need that to be a little bit deeper. Great, that's floating around nicely in the middle. So, okay, so here it is. We're up and running. So the nice green liquid that I mixed is in there. The heater's in there and turned on. I've got my copper bar across the middle with the stainless steel wired to it going down into the item that's actually being plated. That's my electrical connection. I've got my titanium wires going into nickel anodes, 3 of them in there. And yeah, each anode is about, I think 12, 15 square centimeters area. So there's a lot more area on those anodes than there is actually on the item I'm plating. So I've got my negative connected through the center. I've got my positive connected on my anodes. And if we swing over here, I've got my current limited to 0.3 amps, which is about right for the size of the object that I'm plating. So roughly speaking, I'm plating at 16 milliamps per square centimetre. Looks like we're about to go off the top of this thermometer, which tops out about 30. So this pond heater will heat it to about 40 centigrade, something in that region. Yeah, that's it. I'm going to leave that now, go and have a cup of coffee. I'll come back in half an hour. And I guess I'm going to have to take this out and see how it is. Now, I'm not expecting perfection. I purposefully left a bit that looked a bit unclean, because I'd like to see how that pans out in the end product. I'd like to understand what that looks like, because this is just an experiment. It's just a tryout before I do things that are a bit more critical. And it's good to try things like this out, but hopefully it will be at least pretty good. So let's turn off the power and take it out. And look at that. Okay, so here we go. This is literally as it's come out from the plating solution. I haven't polished it or anything else. And yep, you can see a pretty good reflection of my lab in the top. Certainly the lights on the ceiling and things like that are those highlights. And yeah, so it's pretty good. There's a couple of points that are a little bit duller, and they are where I said when I was cleaning it that I hadn't really cleaned it enough, but I went ahead anyway. And I kind of did that on purpose, because it is sort of useful when you're experimenting to kind of find out what's good and what's bad. You don't just want good results, you want actual bad results so you can learn from them. So this is pretty damn good though. It will look absolutely excellent refitted onto my lathe. Certainly better than the somewhat iffy brass looking thing that was getting all tarnished and things. So this will wipe clean, and it won't tarnish or anything like that. The brass seems to be attached, perfectly. I've had to sort of scratch at it with my fingernail. There's no tendency for it to want to break away or do anything like that. The coating is uniform. It's chrome-like, which is what I hoped for. For some things I might not bother to put the brightener in which case it would come out dull, but this is pretty good. If I put something near it, we can kind of see how mirror-like that finish is. And this is basically, I mean, when I made this, I just turned it on the lathe and gave it a quick polish. I didn't bother trying to take all the machining marks out or anything like that. And those machining marks are still there. They're perhaps not quite as visible as when it was pure brass. But overall, yeah, really, really impressed with that. So I, of course, bought a kit for this for all the different chemicals, but there are only 3 chemicals in the actual electrolyte that you use for doing this: nickel sulfate, nickel chloride, and boric acid. And of course, I did add a nickel brightener to make it this chrome-like finish. But yeah, a kit would be a good idea if you've never done it before, I think, because it'll give you all the information that you need to get started. And I will link in the kit that I used down below. So anyway, if you enjoyed that, please like the video. Please subscribe if you haven't already done so, because I'm a very small channel just starting out, and those subscriptions really, really matter to me. And of course, please leave comments down below. If you give it a go, then let us know how you get on. And I'll see you next time. You take care and have fun.